And now for objective, first for compression molding, we aim to analyze how changing preheat times and charging weight affect the final geometry. Second, for screw extrusion, our objective is to monitor how variation in temperature and speed influence the surface uniformity of the extruded filament. Third, for injection molding, we look at the specific effect of the barrel temperature and injection speed on overcoming mold filling defect. Finally, for our galling time analysis, our objective is to map out how different base to hardness ratios directly govern the cross-link rate of a thermoset.
This flowchart shows the methodology of our project. First, we select two materials, which is polypropylene and silicone rubber. For polypropylene, we use three manufacturing process. In compression molding, the parameter we use are preheat time and charging weight, which is a ratio 733, 93, and 53 in units for 48 gram, 55 gram, and 60 gram. In injection molding, we use various temperature, which is from 190 Celsius, 195 Celsius, and 200 Celsius. And the screw speed is from 1 to 25 RPM. In extrusion, the parameter temperature we use is 180, 200, and 220 Celsius, and the speed is 50 and 20 RPM. For silicone rubber, we study the gelling time by changing the mixing ratio, which is 0.5 ratio 1, 1 ratio 1, and 2 ratio 1 with gelling time for 5, 7, and 2 hours. Finally, we run the process, analyze the result, and draw the conclusion based on the best performing parameters processing.
Evening, Doctor. Okay, so I will present my our group proposed parameter for compression molding and extrusion. So for the compression molding, our group used 5 samples. Sample A is the standard 7 to 3 to 3 samples in 40x gram, expected smooth and uniform. And for the sample B, use longer preheat 10 to 3 to 3 in 48 gram. Expected it is the better flow and finish. Then sample C use 9 to 3 to 3 in 48 gram also. So expected is slightly better distribution. For the sample D, use more materials 7 to 3 to 3, but it's used in 55 gram. Expected trickle with some flash. For the sample E, use 60 gram. Expected more flash and size variation. For extrusion, our group test 2 speed and 3 temperature at 20 RPM. When the 180 degrees Celsius, it will look like a rope and enable. When the 200 degrees Celsius, that will smooth and good. For the 220 degrees Celsius, it will too soft and may sag. And when the 30 RPM,
molding we use PP material with two types of parameter, which parameter of injection speed and parameter of barrel temperature. Actual speed we use actual sample, which is A, 20 RPM for sample B and 25 RPM for sample C. However, for barrel temperature, actual sample A, temperature 190, sample B 195, then sample C is 200. By expected observation, for 10 RPM plus 190 degree may produce stable filling with good part quality. For the next 195 degrees Celsius may improve melt flow and produce a smoother surface. For 25 RPM with 200 degrees Celsius may provide faster filling and better flow, but may increase the risk of flashing or material degradation. At 190 degrees Celsius, melt flow will be slightly restricted, increasing the risk of short. At 195 degrees, the material may flow more smoothly with improved filling. At 200 degrees Celsius, the melt may flow easily to produce a smoother surface, but excessively heat may cause thermal degradation. However, for gelling time, also same material, which is PP. For parameter A, it is mixing ratio 101 for sample A, 0.5 with 1 sample B, and 2 1 for sample C. Parameter